All right, let's get started. I'm Jim Allen Wallace. I do product marketing for AI here at Redis. Really excited to talk with you today about Redis AI. So here at Redis, we help customers build fast AI apps fast. So let's get started. So really, interest in AI has dramatically accelerated for companies in the last year. And a year and a half ago, ChatGPT launched, and it was the fastest ever app to gain 1 million users, and it did it in less than a week. Overnight, it was on the top of everyone's tongue with predictions on how it's going to reshape companies, it's going to reshape industries. And Redis had already released our vector database. We made it generally available by the time that ChatGPT came out. But if you fast forward a little bit into 2023, last year, there's an explosion of LLMs. There's a whole new wave of companies that were started after ChatGPT that built new offerings for what's been dubbed generative AI. It's generative because AI large language models or LLMs can easily do what was really hard to do before with AI, which was to generate quality content. And ChatGPT was generating words and sentences, and other companies like Stable Diffusion were making AI art with just prompts of a few words. Many competitors followed. Google launched their competitor Bard, and a lot of source available models came out. And OpenAI didn't take their foot off the gas. They made a big upgrade, shifting from GPT 3.5 to GPT 4. Redis also expanded our AI use cases with more support and integration with our release 7.2. And then you look at today, 2024, AI investment continues to accelerate. Companies have poured money into generative AI, with most companies more than doubling their investment. NVIDIA's CEO, Jensen Huang, claims that Gen AI will be bigger than the internet by far. And his company, NVIDIA, doubled in valuation in less than a year to become the third biggest company in the world, all based on the hopes of Gen AI. And Redis continues to ship innovation. This year, we released the Redis Vector Library, and it helps customers develop Gen AI apps faster. And companies race to deploy Gen AI. 79% expect to deploy capabilities within the next year. Everybody's afraid of being left behind. Walmart and Wells Fargo are among the big name companies that quickly built and released AI chatbots to leverage the capabilities of LLMs to help their internal employees and their external customers. And Redis has continued to double down on our AI, and we've expanded our AI team, and we're helping hundreds of customers build their own Gen AI apps. So we'll talk about that today with you. AI models continue to have gaps, though. Even as models get bigger and better, there's trade-offs and weaknesses that researchers are working to improve. Training data is stale. LLMs can only answer from their training data, and that training data is locked in a point in time. Real-world applications need access to current data or proprietary information that wasn't available to the model at the time of training. This leads to AI apps providing old or incorrect answers. And this will be what our demo is about today. And they're costly to scale. So models keep growing in size, but that makes them more expensive to run and slower to get results. And improving runtime costs continues to be an area of research across disciplines. Companies in each use case has unique requirements and trade-offs, and they'll use specialized models and systems that fit the needs of what they're trying to do, rather than just use the biggest model that they can. And there's no short-term memory. So interacting with LLMs doesn't retain any information that a user or application's provided. And it creates an awkward interaction when it doesn't remember what the user just said or what a program just sent it. So attempts to correct this can be costly or poor quality, leading to a bad user experience. We'll show how to improve that as well. And there's slow responses. Current models take several seconds or more to generate answers or for a user or for other programs. And as models are getting more advanced, they also get slower as each step requires more compute. And additionally, what we're seeing is a chain of different models put together. And as you get more chains in the process, then you have more lag time and it slows down the answer to that user. To address these challenges, specialized tools are being used in AI systems to improve results and accelerate responses. Just like cars use specialized systems for power generation, cruise control, and braking, modern AI systems too use separate components to optimize for performance and cost. Sam Altman, the CEO of OpenAI, said last year, "The age of the giant model is over, and future innovations will come from clever ways to combine existing pieces." And we're already starting to see that in action. So the first of those, RAG, which is what our demo will be about today, is the most popular technique It's retrieval augmented generation, and it's a method that marries the generative power of LLMs with the grounded source materials from vector databases to make AI answers more accurate. And semantic caching, it's a way of answering each question and that are stored for that have been previously stored. So semantic caching answers frequently asked questions that eliminate the redundant calls to save time and money from a RAG methodology. And for LLM memory, the models themselves have no memory other than pieces of the data that they were trained on. So to make functional systems, system designers are connecting LLMs to the right memory coming from users, coming from other programs, so that they have the data that they need to perform the task at hand. And another trend that we're seeing is AI agents. So an AI agent performs an individualized function, and by combining a fleet of agents, complex tasks can be broken down and completed more efficiently and with higher quality with agents. But each of these steps adds complexity and adds lag. So this is where Redis comes in. As the needs have changed with Gen AI, Redis continues to evolve too. We help you connect to real world data. We enable LLMs to connect to data with our vector database utilizing RAG, that we'll talk about here with the demo in a little bit. And we continue to push the boundaries on how fast we can retrieve that data for customers and enable customers to scale your real-time AI apps into production. We scale efficiently. Customers can easily scale to thousands and millions of users while concurrently serving all of their requests with the performance that you've come to expect from Redis. We're battle tested, and Redis is used by some of the largest organizations in the world because the customers trust our security and our reliability. And we help infuse LLMs with memory. We help AI apps become more personal and useful by adding memory to LLMs to ensure the conversations are relevant and helpful to the user. We offer everything that developers need to get quickly set up with session management for their AI apps. And we accelerate AI responses. Another way that we help customers for real-time AI is with AI feature stores. So machine learning models have to take calculated features or variables and use those inputs to instantly make predictions about user behaviors. For something like online shopping product recommendations, every additional bit of speed increases the chance that the user will buy. Customers turn to Redis to solve the challenges with today's AI. We continue to listen to our customers and innovate together so we can solve your toughest challenges. And because we already offer solutions for these top AI instances, customers can move much faster to build and deploy their AI apps. Here's a couple ways that people are using it today. And we help you with your most critical AI needs across use cases, across industries. So the one that we're going to be talking about today is a chatbot with RAG. And Gen AI chatbots are particularly useful in customer support or for any knowledge worker that spends a lot of time looking for the right information. And we power retrieval augmented generation to make those chatbots faster and more useful. We also do document search and deduplication. We can help companies identify which documents are duplicates and replace them or update them. And we can extract the relevant information and provide accurate search results. This helps companies find the information that they're looking for even faster. And we also empower AI agents. So these agents can independently do research, summarize, or write emails. They can interact with other agents. And we store all the necessary data for agents to make the performance snappy so you can get fast answers even from several interconnected agents. Other use cases that we've seen a lot with customers, fraud detection or anomaly detection. And we can deliver predictions in a fraction of a microsecond so that users can just swipe their credit card, bad actors are stopped in their tracks. As much as 20% of financial transactions are fraudulent, and we help financial institutions stop this in real time to protect customers. Another one that we see for retail customers particularly is product recommendations. So as users are shopping online, they're surface products to buy something new that might be a fit for their needs. And providing the right product at the right time to the right user can make all the difference in getting that customer to buy. And Redis powers fast and reliable recommendations so that you can grow your revenue and make your customers happy with what they were looking for. And lastly, content generation. Companies need emails generated or need meeting notes summarized. Redis can do this quickly, so humans can act on it in real time. You don't need to wait for the end of the meeting, wait for another 30 minutes to get the meeting notes back. You can just get it in real time and then be able to send that email right away. The use cases for AI are rapidly expanding, and Redis is working on new uses every day. So I'll talk a little bit here about our demo. And what this is going to be an example of a chatbot that a lot of companies are using, and they will set it up with internal documentations. This could be hundreds, this could be thousands or millions of documents that are structured, tables, or it may be unstructured PDFs, slides, PowerPoints, audio files, video recordings, and use all of this to surface answers for their internal users. So the example that we're going to use is one publication by the IRS. It's a lengthy document. It's like 40 or 50 pages and has a lot of dense information, but then we're going to ask specific questions to get a specific answer out of this document with our virtual chatbot. It's helping enable customer service agents or anyone that's looking for information to be much faster, and much more accurate at their job. So before I jump into the code, I want to lay out the architecture on how this works. And for this demo, we're working with Google with Vertex AI. And I want to break the demo down into two pieces. The first one on the top right is really the pre-work. This is the embeddings. And then the bottom piece is the retrieval, and that's going to be at runtime. So for example, a company's going to have all of their data stored in a cloud, perhaps Google Cloud Platform. They're going to have their source files, their cloud storage. They may have structured data. They might have a BigQuery. And then using a chunking algorithm, we're going to take the information from all of this and then form it into an embedding with an embedding model. And what that does is the embedding retains the semantic meaning of, it could be a paragraph or a chapter or of a PowerPoint slide or of an audio file, and it will store that as a vector embedding in the Redis vector database. So we'll store vectors for all of the different files and parts of files so that users can quickly go reference the information that's related to what they're asking about. So now we've got everything set up in the vector database. Now the users can come in and ask their questions. Many users at scale. And so for example, someone's going to ask, how can I file electronically with the IRS? And that user question is going to go to the LLM application, and it's going to check the semantic cache. Maybe somebody's already asked this before. If you ask something like, what's the due date for your taxes? Then that's probably been asked, and you can pull that directly out of the semantic cache. It's 15 times faster. It saves a lot of cost. You skip this whole step for a better user experience. If someone hasn't asked this particular question before, then we're going to have to go through the RAG, or the retrieval augmented generation process. So the user query will also be turned into a vector embedding with the same embedding model. And we're going to check for any related vectors in the vector database that might be similar to the question that the user asked. You might have a paragraph or a couple sentences on when the due date is for filing your taxes. And it'll pull those relevant document chunks, combine that with the user response, the user question, and send that over to Gemini as a model. You can use first or third-party models, and the LLM will generate a response from that source document and the question that the user answered. So you'll get a human-readable, very understandable answer back to the LLM app that's returned to the user. Great. Let's jump into some code. Great. So here we have a notebook that's going to walk through that architecture that I showed. We'll skip over the intro and adding the prerequisites, and we'll start with obtaining the data set. So we'll reach out. This could be an ingestion that's going to take all of your company's internal documents and store them as vector embeddings. In this case, we're going to use the IRS document that we talked about. We're going to go ahead and set up the embeddings, and then we're going to generate them. So for each chunk, we'll utilize LangChain here. Each paragraph, each chapter, we're going to capture the semantic meaning of that section, and we're going to turn it into a vector embedding. And then we'll use these for being able to find the relevant information when we're when we run this at runtime. And then we'll create the index in Redis. So what this allows us to do is very quickly search for that right vector, search for that right information. The index is sorted to be able to find that as quickly as possible so that users can get that real-time response, that snappy performance that really makes them happy and delighted and prevents users from churning. So you'll see in a particular index, you're going to have the chunk ID, you're going to have the text embedding, the text that goes with it, you'll have the vector, and other information that would go along with that. So once we have all the vectors stored, we have finished the embedding piece, that first setup stage that I talked about in architecture, and we're going to move on to runtime. We're going to talk about the query. So we can use Redis VL to perform a variety of vector search operations. And here in this notebook, we're going to answer a simple query: what is TCC? And what this is going to do, like I talked about on the architecture, is it'll take this question, turn it into a vector embedding, and then it's going to go and return all of the related sections from that IRS document that are related to this question. And you can see them down here. So each of these are about a paragraph, a little bit longer, and you can paginate the results. You can look through for exactly what you want. If you want to sort it based off of other criteria, or also look for specific keywords, there's different ways that you can return the right information that you want. And so that's our vector embeddings. That's the related information to our question, what is TCC? Now we're going to go to building the RAG pipeline. So we're going to take those vector embeddings, the information that's related, and we're going to start to return it to the user. So we'll set it up. We'll use Vertex AI and the generative AI model. We'll use Gemini in this instance. And with Google, you can use a lot of different safety settings, make sure that the responses that come back are appropriate. If someone asks a question that isn't covered in the source documents, then you can say, I don't know. You can decline to answer that for the user rather than making something up, a hallucination that is misleading to the user. So we'll use all that. We'll set up our baseline retrieval, and we're going to give it a little context just so it knows some information about this user to make the answers a little bit more human understandable. And then we'll generate a list of questions. So up here, we're going to start with what is TCC? We'll see the answers for that. But there's other questions that you can ask, and you can send these rapid fire as well. You should apply for TCC. What's a JWK? Should I buy a yacht? And then you'll see we're going to go through that RAG process that we outlined in the architecture. We're going to generate the embeddings. We're going to pull information back from that vector database of related chunks. And then we're going to send that to Gemini, the LLM, and we're going to get an answer back. So for TCC, you get the answer. TCC stands for Transmitter Control Code. Great, super helpful, exactly what I was looking for. And then for that last question, should I buy a yacht? You get the answer back, I don't know. And the reason for this is that this opinion question isn't covered at all in this IRS document on whether you should buy a yacht or not. So rather than make up an answer, the LLM with the correct governance will return the answer that says it doesn't know. So second, we're going to fire up that LLM semantic caching. And this is the short circuit that we talked about in the architecture. So once the answer is already saved in there, then you can skip the RAG process. You can return answers 15 times faster, and you can save cost. What we've seen is about 31% of enterprise queries are duplicated, are redundant. So rather than having to go ask that again and ping the database and incur additional costs with the tokens to the LLM, it saves all that because that answer is already saved in memory in the LLM semantic cache, and then you can get that answer that much faster. So we'll set up all this information, and then we'll ask the query, what is a JWK, JSON web key? And you can see here, it takes about a second and a half, 1.48 seconds to run. And that's about the timeline for the RAG to go end to end. But if we ask that question again, and it's a little bit different, but similar, what's a JWK? It will check the semantic cache first, realize that this similar and related question already has an answer. So it's just going to pull the answer right back out of cache rather than have to go and hit the database and hit the LLM again. And that second time, it's 0.11. So it's about 15 times faster to be able to get the answer. So next, we're going to show like what a simple chat interface could be. We can use Gradio and download that, and then we'll use that as part of our notebook. And here you can see, you can ask, what does TCC stand for? And it will answer TCC stands for transmitter code, just like we said. And if we want to, okay, I hope that was helpful. I'll switch back over. And lastly, what I want to leave you with is that we unlock speed so that you can innovate faster. What I hear from customers most is that they're very excited. They want to get started with Gen AI as fast as possible. And Redis enables customers to do that because we're fast. We provide high speed, high performance. You don't have to worry about the optimization. You don't have to worry about, is this going to return the result that I want quickly? Customers know us for speed, and we can help accelerate that experience. We're flexible. Every week there's a new model that's coming out. There's a new integration or a new tool or archetype or paradigm that companies want to use, but they also want it to work with their existing tech stack. And being able to plug in a new system is not easy, particularly in production at scale. So Redis has integrations with the top ecosystem partners for AI and for Gen AI. So we help you bring that idea, bring that product to market that much faster. And we're trusted. So 58% of the Fortune 500 companies trust Redis with their data. We're reliable, we have security and compliance, and we're battle tested. We've been doing this for more than a decade at some of the highest volume companies in the world. When companies need to make sure that it works and they need it in real time, they come to Redis. Thanks for the time today. I hope you enjoyed it and learned something. I had a lot of fun doing this with you. And to see what you can do next, I encourage you, check out some of our learning materials on our website. You can learn more about Vector and Redis AI there, or set up time with one of our experts, and we'd be happy to help you see how AI can help your business. Thanks.